Hey, all. Today we're going to talk about angles that are formed again by segments and circles, and this time when they have a vertex that is outside of the circle. So the first way we can see that is when we have two secants. So here I have secant AB and secant CA, and I'm just going to move this up so you can see it better. And what we end up with are two intercepted arcs by this angle. We have a small arc here between the two secants and a bigger arc here between the two secants. Okay, we have a couple other arcs, but we're concerned with the ones that are between the two segments or lines. And so the relationship that exists is this angle here is equal to the big arc minus the small arc divided by 2. So angle ABC, the measure of angle ABC is equal to the measure of arc AC minus the measure of arc DE. And so we're going to measure the angle. Now I'm going to measure my two arcs. Again, remember that I have to add in a third letter here just because of the program. And now I'm going to subtract the two arcs and divide by 2. And you can see that the angle and that two arcs subtracted divided by 2 are the same. So I can move some things around and change the measure of the angle. And I guess once I get past this, there's a measuring problem. But they're the same. Still the same. Still the same. So again, this is another thing where if you write the formula every time, you'll remember it, and then you got to plug things in where they belong. So here I have an angle formed by two secants. So I have a big arc, and I have a small arc. And so I'm going to plug into the formula. 129 minus 57 over 2. Simplify, and find my angle to be 36 degrees. Similar situation, I have an angle that now I know is 43 degrees. It intercepts this big arc that we're looking for, and that small arc. So I'm going to do my big arc minus my small, so question mark minus 59. 43 goes in for the angle. To get rid of that 2, I multiplied both sides by 2. That's how I get 86. And the top just stays here, question mark minus 59. Add 59 to both sides to find that arc to be 145 degrees. So I have one for you to try here. I want you to find the value of question mark, type only the value. So another way that we can have angles with a vertex outside is if we have one secant and one tangent. Remember a tangent line, let me make this a little smaller so you can see the whole thing. A tangent line touches the circle in one place, so if this segment continued on, it would never touch the circle again. And then we have a secant here. Again, this is the angle we're referring to, and we still have a big arc and a small arc. So my smaller arc is AD. My bigger arc is AC. And so if I measure my angle, and I measure my two arcs, now I'm going to do the big arc minus the small arc and divide by 2. And my angle is the same size as the resulting subtraction divided by 2. And I can move this around, change the measure of the angle, and those two things are going to be equal no matter where I put this. So it looks different than the other one, but the relationship still holds. So whenever I have two secants or a secant and tangent, they have the same relationship, so I can solve problems in the same way. I'm looking for the angle. I have HE as my big arc, and I have EG as my small arc. And so I got to plug into the appropriate spots. So 180 minus 70. Simplify that to find my angle to be 55 degrees. Here I'm given the angle this time. I'll go locate my big arc. That's what I'm looking for. And my small arc. Again, the arcs are always going to be between the segments. So this arc over here, CD, it is created by the picture, but it's not one of the arcs that's related here to the angle. I'm going to plug question mark in for arc big, 76 for arc small. Again, I'm going to multiply both sides by 2 to get rid of this 2. Question mark minus 76 stays unchanged. That becomes 130, and I add 76 to both sides to find my big arc to be 206 degrees. So I want you to try this one. Find the value of question mark, type only the value. The last way we'll see this sort of vertex outside is when we have two tangents. So here I have two tangents, AB and AC. They both only touch the circle once. If these continued on forever, they would never touch the circle again. The same relationship holds true. The big arc minus the small arc divided by 2 will be equal to the angle. So we have the two tangents. It's nice because we only have two arcs, and it's pretty obvious. I think it's pretty obvious in all of them which one's the bigger one. So we have this arc ADC is the big arc, and this arc AC is the small one. So let's measure the angle. Measure my arcs. And now I'll subtract my big minus small, divide by 2. Again, you can see that those two things are equal. So there is a unique alternate method here, or alternate relationship, that I think might be a little simpler. When I have two tangents, the other thing that is true is that the angle plus the minor arc, or the small arc, is equal to 180. So my angle and my smaller arc always add to 180. So let me move this around. I've added the measurements, and you can see right now they're equal to 180. And as I move this around, you can see the angles changing. Big minus small over 2 is changing. But that 180 down here is never going to change. My angle and my small arc always add to 180. I find that working with this relationship simplifies problems with two tangents a little bit. And I can point out why it might get complicated to use this method with two tangents at another time. So I'm going to stick with the one that I think works best, and if you like the other method, that's totally fine too. So I have this angle that's 70 formed by two tangent segments. I'm looking for the big arc, and I have this small arc that I don't know how big it is yet. But I'm going to find it by using the relationship that the angle and the small arc add to 180. Be careful with using the word supplementary. They're not supplementary because they're not both angles, but they do add to 180. So my angle plus the arc I don't know equals 180. If I subtract 70, I find my small arc to be 110. And now I only have two arcs in this picture. They should both add to 360 because they make a whole circle. And so I'm going to subtract 360 minus 110 to find my big arc to be 250. Again, I like that method. I think it simplifies things. If you use the other method, it might get a little complicated. But if you do want to use the other method and you're a little stuck, make sure that you ask me and I'll help you through it. Again, I have an angle. This time what's nice is I'm looking for that small arc. So I'm going to use the relationship that they should add to 180. Subtract 65 from both sides to find the small arc to be 115. So try this, give this one a try, find the value of question mark, and type only the value.